This is our 40 by 60 foot pole barn built into the side of a mountain here in southern Utah on our homestead. Today I'm going to give you a complete breakdown of the costs to build this barn and all the associated ancillary costs like the excavation and the concrete and running all the conduit and culverts. I'll also give you a complete tour inside and out towards the end of the video and explain why we did some of the things that we did, especially tied in with our photovoltaic system. They really work in tandem and they had to be done really about the same time. So it's been roughly 2 years since we finished the barn. We finished this in late 2023. And let's jump in.
Why build a barn in the first place? Well, for us, it was about 4 main things: protecting our tools and equipment, housing our off-grid solar power system, having a place for build and repair projects, and creating a space for the RV. Without a barn, you're constantly battling weather, sun, the snow, of course, and for off-grid living, that means a shorter equipment life and a lot more headaches. So this is sort of a giant man cave, I guess, if you will. It's just the best for all of these projects. I spend a ton of time in this barn. Let's talk site prep and foundation work. I started this project thinking I might be able to do it with my own backhoe. So I did all the tree removal and I cleared the land, and that turned out pretty well. Things were going somewhat smoothly until I started to really get into moving the dirt. I realized that I'm going to tear this machine into bits. There won't be anything left of it by the time I finish this project. There are boulders that are almost the size of this backhoe under there. So we ended up calling a guy that brought in his excavator, much larger machine. Now this is an appropriate size piece of equipment for the job that we were taking on here. We needed to move quickly. We had construction planned and we wanted to get everything in place, especially the concrete, before winter set in. As soon as it gets really cold, everything becomes much more complicated. He had to use this ripping tool to dig out these massive boulders, and eventually he started to get some good headway. And you can see he's just moving metric tons of dirt from where the barn's going to go over to where the solar array terrace is. We have 2 terraces that we made with the dirt from the excavation of the barn, one for the solar array and one for the extended driveway. This dump truck was really just moving about 100 yards back and forth, just bringing the dirt from where he was excavating it over to where we're extending the driveway. We also needed 3 conduits to run from the house over to the barn. So we moved this huge boulder, trenched underneath the driveway, and brought those up right about where the corner of the barn is going to be. So we put elbows on those and brought them up vertically and stubbed them off until we can finish construction. This is the solar array terrace taking shape. All of that soil came from right here where the barn is going to go. And the rest of that soil went right over here, which is the extended driveway where we can nose the truck in to back the 35-foot fifth wheel into the barn. This is a pole barn, and unlike steel building construction, the footing does not go around the entire perimeter of the structure. An auger is brought in and they drill very large footings for each individual support post. And then after the structure is built, then we'll come back in and put in the slab and all the surrounding concrete. This is a Google Earth of when I was actually designing the general area of where I wanted the building to be and how I wanted it positioned. I knew I would want a larger building. I was thinking, man, a 60 by 80 would be great, but we didn't want to go too big and take on too much expense. But I used renderings to get a general sense of where I wanted the doors. So 2 big roll-up doors on the front, windows down the sides, and a pedestrian door on both sides. 1 roll-down door or ground level door on the rear of the building. And then I used a 40-foot semi-trailer as sort of a placekeeper so I could get a general idea of how the RV was going to fit in there and how much room aside from that we thought we might need for, all the other equipment, the shelving and the gantry crane and all the other components. And it worked out pretty well. Let's talk about some of the wiring and design choices. As I mentioned in the beginning, the photovoltaic system or the solar power system and the barn really needed to happen at the same time. We needed the dirt from where the barn was excavated to go up to make a flat spot for the array. And we also needed a place to put the inverters and batteries indoors so that it could be protected from the weather and so we could keep it at 50 degrees or warmer during the winter. And so all of this really tied together. This is the load box that's in the front of the barn, and you can see where we wired the barn. This is before we put the insulation in and put the 3/4 inch plywood 8 feet up from the bottom. This obviously before the slab was poured too. But this is great. I documented all this by video so that I can always go back and know where every single wire in the barn is. So if I wanted to add something or drill somewhere, cut somewhere, I know where all the wires are just by going back and looking at this video. But we also have it staged for a backup generator. We're going to put a propane generator in the back of this barn. And you can see those two stubs there. One runs up to the load center in the front of the barn, and one runs out to the solar array. And then from the load center to the front of the barn, it runs over to the house. The sectional doors are insulated, and they are 12 feet wide by 14 feet tall. We have these side control motors or jack shaft motors. These are commercial grade, a little bit more expensive, but it's the right way to go, I think, for this size door. We have these motors on the two front doors, and the one in the rear is manually operated because we hardly ever use it. I put this 15,000 BTU all electric space heater up in the corner here. I set it at 50 degrees and only turn it on obviously when it's really cold outside, because we don't really need it to be that warm in the barn. The reason why we need a heater is, one, to keep the batteries and the inverters happy on those really cold days, but also to keep from having to winterize the RV. For energy efficiency, I went with these low E dual pane windows. And in addition to the front little driveway area, we've got this walking path that goes all the way around the perimeter of the barn. Really nice. It also keeps the water from dripping off the roof and splashing up on the siding. This was an extra, but I would say well worth it. We didn't go with rain gutters, but we did go with these snow rakes that just keeps the snow from sliding off onto the pedestrian entry door areas. If you didn't see my solar video, I'll put a link in the description, but these solar converters communicate to the internet so that I can see the system live on my phone. Now we get the internet here via Starlink, but it doesn't quite reach out to the barn. So I have this Wi-Fi extender. We've got this super bright motion sensor LED in front of the two main doors, as well as one above each pedestrian door. And inside, I've got really simple lighting controls, as well as these 4-gang outlets everywhere, because you never really think you need them, but you always do. We've also got the 50 amp here for the RV. And up above, we've got 6 ultra bright LEDs, which is basically like having the sun inside your barn. You can't cut corners on water drainage if you want a really secure barn that's going to last forever. This is a 24-inch diameter culvert that runs several feet underneath the main driveway out to the other side and down the mountain. All around the entire barn, we have about a 2.5 foot deep trench. And over on this side of the barn, we've got a 12-inch diameter culvert that runs underneath the driveway that goes up to the solar array. So a little bit of planning, and we have not had any problems. Here in Utah, we get really crazy downpours. You've probably seen some of the footage from Zion National Park where they have flash floods in the Narrows. There's no vegetation, so it just runs off of this topsoil and can really cause a lot of problems if you don't plan for it. Okay, so here's the total cost breakdown of everything it took to build this barn ground up. The structure itself was $144,254. That's the roof, the walls, the sectional doors, all the insulation, the plywood on the walls on the inside, the concrete, the sidewalk around the edge, everything. The excavation was $13,890. That includes the machine and the man hours of the guy sitting in there for 3 weeks. The electrical was $10,500. That's all the wiring, switches, heater, all of that. The permit was $1,296. Now, believe it or not, we did come in a little bit under what we anticipated our budget would be. The total was $169,940. Well, I hope you enjoyed that video. Now, I would love to hear the feature that I left off this barn that you would put on your dream barn. Leave that in the comments below. Don't forget to give this a thumbs up and subscribe for more off-grid homestead living videos, and I'll see you on the next one.